and a velocity, vi2, of negative 6 meters per second. Find the final velocities for VF1, VF2 of both the first and second bumper car.
There are quite a few steps involved to solve this problem, so let's work through them one at a time.
The first thing you need to do is take the formula for the conservation of kinetic energy and rearrange it so all M1 factors are located on one side of the equation and M2 factors are on the other side.
Next, you'll need to factor out your squares on each side of the equation.
Once you've got this done, you'll want to switch over to the formula for the conservation of momentum and get the mass factors on either side of the equation just like you did before.
You'll then need to divide your factored out equation for the conservation of kinetic energy by your factored out formula for the conservation of momentum.
Now we'll rearrange this equation to put VF2 by itself on one side of the equal sign.
This equation can now be plugged back into the original formula for the conservation of momentum to solve for VF1.
At this point, you'll want to get the VF1 turn itself on one side of the equal sign.
At last, we're ready to insert the information from our problem to solve for the first final velocity.
Finally, now that we know one of the final velocities, we can plug back its value into the original formula for the conservation of momentum to solve for the second final velocity.
M1 times VI1 plus M2 times VI2 equals M1 times VF1 plus M2 times VF2.
200 kilograms times 4 meters per second plus 160 kilograms times negative 6 meters per second equals 200 kilograms times negative 4.89 meters per second plus 160 kilograms times VF2.
800 kilogram meters per second minus 960 kilogram meters per second equals negative 978 kilograms meters per second plus 160 kilograms times VF2.
Negative 160 kilograms meters per second equals negative 978 kilograms meters per second plus 160 kilograms times VF2. 818 kilograms meters per second equals 160 kilograms times VF2. 5.11 meters per second equals VF2.
When two objects collide, one of two types of collisions can occur.
In an elastic collision, objects bounce off each other after colliding.
While in an inelastic collision, the objects that collide stick to each other after the collision.
When solving one-dimensional collision problems in a physics course, what we're really working with are conservation laws. For an elastic collision, there are two of these conservation laws that apply. The first is the conservation of momentum, and it states that the total momentum before and after the collision must be the same. Unlike the conservation of momentum, the second conservation law applies only to elastic collisions and not inelastic ones. It is the conservation of kinetic energy which tells us that the total kinetic energy must be the same before and after the collision. You will use these two conservation equations constantly when working on problems that involve one-dimensional elastic collisions.